There's something deeply humbling about staring into the vastness of space. It's like gazing into a time machine, a mirror reflecting not just the stars, but ourselves. On Christmas Day 2021, humanity launched something extraordinary, a machine that would let us look deeper into the universe than ever before. A golden eye floating 1,000,000 miles from Earth, waiting to show us the invisible. This is the story of the James Webb Space Telescope, the most ambitious space observatory ever built. But to truly understand its journey, we need to go back to the 1990s, when the Hubble Space Telescope had already given us breathtaking images of galaxies, nebulae, and the expanding edge of the cosmos. But Hubble, as powerful as it was, had limitations. It saw mostly invisible and ultraviolet light. What it couldn't see, what remained hidden, was the infrared universe. And that's where the deepest secrets lie, the birthplaces of stars. Wrapped in clouds of cosmic dust, the first galaxies after the Big Bang, and perhaps even the atmospheres of alien worlds. Scientists and engineers knew they needed something far beyond Hubble, a telescope that could not just look at stars, but witness their formation. Not just discover exoplanets, but analyze their skies for signs of life. A telescope that could see back 13.5 billion years to the very beginning of cosmic time. And so began the journey of building Webb. But building such a telescope wasn't easy. In fact, it became one of the most complex engineering projects ever undertaken. Over 25 years, more than 10,000 scientists, engineers, and technicians from 14 countries worked together. NASA led the mission, with strong support from the European Space Agency and the Canadian Space Agency. The vision? A telescope that would unfold in space like an origami flower. Why unfold? Because the James Webb Telescope is huge. Its primary mirror spans 6.5 meters, more than twice the size of Hubble's, but no rocket could carry something that large in one piece. So the engineers designed it to fold up for launch, and then self-deploy once in space. And that wasn't even the hardest part. Webb would observe the universe in infrared, meaning it had to be kept extremely cold, close to 233 degree, 388 degree F. Even a little warmth from the sun or earth would blind its vision. To protect it, engineers built a 5-layer sun shield, each layer thinner than a human hair, the size of a tennis court. It had to block out heat and light from the sun, earth, and moon, and it had to unfurl flawlessly in space. Failure wasn't an option. The launch date was pushed again and again, from 2007 to 2010. Then 2014, 2018, 2020. Each delay brought skepticism. Costs ballooned, from under $1 billion to nearly $10 billion. Some called it a failure before it ever left Earth. But then on December 25, 2021, from French Guiana, Webb finally took off aboard an Ariane 5 rocket. The launch was perfect, and that's when the real test began. Over the next 30 days, Webb traveled to its final destination, the second Lagrange Point, or L2, a spot in space about 1.5 million kilometers from Earth, where the gravitational forces of the Sun and Earth balance out. From this point, Webb can remain stable, shielded from the Sun, and see the cosmos in stunning clarity. During those 30 days, 1 million things had to go right. Over 300 single points of failure, from deploying the sun shield to unfolding the mirror's 18 gold-coated hexagonal segments to aligning them with nanometer precision. One wrong move and the mission would fail. But miraculously, everything worked. The telescope unfolded like a piece of space ballet, delicate, complex, and breathtaking. Then came the tuning, weeks of aligning mirrors and calibrating instruments. And finally, in July 2022, the world held its breath. Webb's first images were released, and they were nothing short of historic. A cosmic landscape of deep fields filled with galaxies never seen before. The shimmering Carina Nebula, showing towering clouds of gas where stars are born. The deep light of the Stefan's Quintet, capturing interactions between galaxies. And perhaps most astonishing, the spectrum of an exoplanet's atmosphere, revealing water vapor, cloud patterns, and more. In a single moment, Webb didn't just capture images. It changed our relationship with the universe. We weren't just looking at pretty pictures. We were gathering data that could answer the biggest questions of all. Where did we come from? Are we alone? What is the fate of the cosmos? With Webb, we can now peer through dusty veils to watch stars being born. We can observe the earliest galaxies, formed just a few 100 million years after the Big Bang. We can scan exoplanets for signs of life-supporting molecules like oxygen, methane, and carbon dioxide. And one day perhaps even detect a planet with biosignatures, signs that life exists beyond Earth. This is no longer science fiction, it's real. But the journey is far from over. Webb's mission is planned for at least 10 years, and with precision navigation and power conservation, it might even last 20. In that time, it will explore supermassive black holes, cosmic collisions, and the dark matter web that binds the universe together. And as it looks outward, we're also forced to look inward. Because space has a way of humbling us. It reminds us how small we are, a pale blue dot floating in the vastness. Yet at the same time, how remarkable it is that we're even able to ask these questions, let alone build machines to find the answers. We often talk about technology as something that connects us, phones, satellites, the internet. But the James Webb Space Telescope connects us in a deeper way. It connects us to our past, by revealing how the universe began. It connects us to our future, by showing us what's out there. And it connects us to each other, because all of it, is a shared human achievement. We built this together, across borders, languages, and disciplines. It's not just a telescope. It's a testament to curiosity, cooperation, and courage. The courage to imagine, the courage to wait, and the courage to keep looking, even when the answers are far, far away. So the next time you see a picture from the James Webb Telescope of galaxies colliding, or light from the beginning of time, remember this: you're not just seeing the universe, you're seeing humanity's reflection in it. Because in the end, the stars don't just tell us where we're going. They remind us where we came from. And maybe, just maybe, they whisper, "You're not alone.